Good afternoon, students. Today we are going to do our experiment number 12. So, regarding this part, experiment number 12, I am going to prepare two classes. In one, I will tell you how to prepare micronutrient concentrations, and in another one, regarding the macronutrients, how to calculate the doses for macronutrients. Okay. So this practical experiment number 12, it is regarding the to study fertilizer application in different horticulture crops. So it is one of the important topic in which you should know how to calculate different doses, whether it is your micronutrient or macronutrient. So here you can see in materials required urea, SSP, DAP, MOP. Some fertilizers are given here. So you should know there are two types, means there are different categories, but importantly you should know there are some straight fertilizers. Straight fertilizers means it will include only one major nutrient. Okay, so example is your urea, SSP and MOP. They will contain one major nutrient. So you should remember urea contain 46% nitrogen, SSP contains 16% P2O5 and MOP contains your 60% K2O. You have to remember this nutrient composition, okay, to conduct. So these are known as your straight fertilizer. Next is your DAP. Okay, this DAP. 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 So DAP, it stands for diammonium phosphate. It is a complex fertilizer. So what do you mean by complex fertilizers? Mean it contains at least two major nutrients. For example, DAP. Okay. So we will write the diammonium phosphate. So what are the two major nutrients it contains? It contains 18% of nitrogen and 48%, 46% of 18% nitrogen and 46% of P2O5. Okay, so this DAP is little bit cheaper, so it is more oftenly you using it uniformly. Okay, so you should know, remember this: straight fertilizers and complex fertilizer. DAP is a complex fertilizer. So all these things you should know. Then after this is your SSP, single super phosphate, muriate of potash, borax, borates, etc. These are all given here. So here the learning objectives of this practical is you should know how to prepare nutrient solution, to know the utility of macro and micronutrients and their application in horticulture crops. Okay. So let's remove this one. So you can see some crops, they used to have some physiological disorder. So what is the difference between disease and disorder? Means disease, it used to cause due to some insect or pest. Okay, and disorder means this is the disorder which is occurs due to the deficiency of some micronutrients or some temperature fluctuations and all. Okay, so that's why application of macro as well as micronutrients both are equally important for the growth and development of the particular crop. So here you can go through this theory of the background. There are 16 most important nutrients for plants. Plant must obtain the following mineral nutrients from their growing medium. So macronutrients, you can see macro means they are required in larger amount: nitrogen, phosphorus, K, calcium, sulfur, magnesium, carbon, hydrogen, oxygen. So to remember this micronutrient, you just write it CHO, that is carbon, hydrogen, oxygen, and NPK, CAMGS. Okay, so likewise you can remember what are the macronutrients: CHO, carbon, hydrogen, oxygen, NPK, nitrogen, phosphorus, potassium, CaMgS, your calcium, magnesium and sulfur. They are required in means major quantity. Okay, and micronutrients means trace minerals. They are required in very small quantity, in very trace means very little amount. Okay, so like your iron, boron, chlorine, manganese, zinc, copper, molybdenum. Okay, so here go to this literature. You it's written in very simple language, you can understand this one. So that's why so what will happen nowadays, the most serious problem is the farmers without knowingly they used to apply overdose of fertilizer. They thought that if they will apply more fertilizer they will get very good yield. So that in turns deteriorate the health of the soil. The plants require only that much of quantity of fertilizers or micronutrient according to their need. If you will apply more also, there is no advantage of that one. Okay, so you can go to all this literature, so you can see the different functions it's given here, iron and all these things. Okay, zinc, boron, copper, manganese, molybdenum, etc, etc. Okay, so you can see here today we will discuss only how to prepare concentration for especially for the micronutrients. So since micronutrients they are required in very small amount, okay, that is trace amount, they are always required in, always measured most of the time in ppm. What do you mean by ppm? Yes, ppm, how to prepare 1 ppm solution is, for example, if you want to prepare, let's take an example of 10 to 15 ppm here. See, 10 to 15 ppm of manganese you have to apply. So that particular substance or fertilizer, manganese sulfate, you can take 1 milligram in per in 1 liter solution. Okay, 1 milligram in 1 liter solution, it is your 1 ppm, and 10 ppm will be your 10 milligram in 1 liter solution. Okay, solution. So let's see how these definitions it comes into being. So 1 milligram, 1 ppm, let's again write it this one. 1 ppm equals to 1 milligram in 1 liter of solution. So 1 milligram, if we are going to convert it in okay, so 1 ppm is your 1 milligram in 1 liter of solution. To prepare 10 ppm, it's quite easy. You just mention that 10 milligram in 1 liter of solution. This is your, so for this you should remember this formula. 1 ppm equals to 1 milligram of the solute in 1 liter of the solution. Next, you can see in calculation part here, concentration of salt solution, percentage weight by volume equals to weight of the salt divided by volume of solution into 100. Okay, so where this calculation is going to help you, let's see some example here. So for example, let's take this example. You want to prepare 0.5% of manganese sulfate here. Okay, so to check the flower drop, you want to spray 0.5% manganese sulfate. So here you want to prepare 0.5% manganese sulfate. Okay, so to, what do you mean by 0.5% means you have to take 0.5 gram in 100 ml of water. That is your 0.5%. Okay, so for example, so here the quantity is your 100 ml, but for spraying, if we require more quantity, then we have to increase this volume, isn't it? So let's take example. So if it requires 500 ml water, means the volume should be 500 ml. The volume we require equals to 500 ml, and the concentration we require equals to 0.5% concentration. So how much of manganese sulfate we have to take? So we have to take the weight of this salt. So in this case, you can use this formula as concentration equals to weight by volume into 100, because this is in percentage. That's why we are going to multiply it with 100. Okay. So now here concentration we require is 0.5. Weight we don't know. Volume we have to prepare 500 into 100. So you just W equals to 2.5. So we have to put 2.5 gram of this particular manganese sulfate in 500 ml of water. That time the concentration will be 0.5%. Okay, so likewise you have to keep on preparation. You can take other examples also, which is given here. Okay, this is, so here there are two concepts you have to remember. This is when the solute you are using is in solid form, you can use this directly, whereas in some cases you can see 0.2% boric acid. So boric acids are available in liquid form. So in that case, what you are going to use? Same, C equal to M by V. So here what you are going to use, concentration you want to prepare. Let's take V, we have to prepare 500 ml itself. Okay, so concentration you want to prepare to 0.2%. Volume or mass you don't know how much you want to take this mass. Okay, volume you want to prepare is your 500 ml into 100. This is for your boric acid. Okay, so what will be the answer here? 1. So M will be your 1. So in this case, since this is in liquid form, so we have to take 1 ml. Okay, so we have to take here 1 ml in. So while preparing this 500 ml, we have to take care. So how much we have to prepare? 499 ml plus 1 ml. Then only the total will become 500 ml. Sometimes you do some silly mistake that you will take 500 ml directly. Okay, so in that case it will become 500 plus 1, that is your 501 ml it will become. So there it will be a mistake. Okay, so in case of liquid, where the solid is your liquid solvent you are using, that time you have to find it out how much quantity is required. Then in total volume you should add it one. For example, if you want to 500 ml, then you want to take 499 plus 1 ml. Okay, then coming to the, so ppm and all we have already discussed. Okay, ppm, how to prepare ppm. Then you have to remember C equal to M by V into 100. Okay, in case of percentage. Then in case of liquid volume, means liquid, then you have to very careful while preparing that solution. Then next coming to bring conversion of a solution. So here you can see another formula is given, C1V1 equal to C2V2. So in this case, if this formula will be helpful for preparing two different concentration, or from one stock solution you can make different solution. For example, you are having one stock solution. So especially see micronutrients, they are applied in ppm, very ppm, 0.1 ppm, sometimes we have to prepare 0.5 ppm, we have to prepare. Okay, so it's very difficult to prepare such a small quantity. So in that case, what we used to do, we used to prepare a stock solution. From there you can prepare the different concentrations from there. Okay, so here we can do one calculation here. So you can write it down, one problem. Question: what will be the final volume of 5 ppm solution of NaA from 100 ml of 10 ppm stock solution? So the question is, what will be the final volume of 5 ppm solution of NaA from 100 ml of 10 ppm stock solution? That means we are having one stock solution of 10 ppm. This is the 10 ppm stock solution, which volume is 100 ml. From there we have to prepare one 5 ppm solution. So how much volume we have to take from here, this stock solution, to prepare a 5 ppm solution we have to do. So here you can see, here we have to use this formula, C1V1 equals to C2V2 here. So C1 concentration 1 is your 10 ppm into V1 is your 100 equals to C2, how much concentration you want to prepare, 5, then V2 you don't know, so you just find it out. This V2 equals to 1000 divided by 5, that is your 200 ml. So you have to take 200 ml from here, okay, to prepare stock solution of 5 ppm here. So likewise you can find it out, and you can use this formula, C1V1 equals to C2V2. The same thing you can say, if V2 is given, C2 is not C2 you have to find it out, then you can use this formula. Okay, so likewise you have to remember this, C1V1 equals to C2V2 here. Then what do you mean by ppm? 1 ppm equals to 1 milligram per liter. You have to remember this. This is also important. This formula is also important. And regarding C, concentration of salt solution, you have to remember this one. For the time you just remember this one, weight by volume, and in case of volume by volume, what are the thing regarding the volume of total, while preparing the total volume of solution, you have to keep in mind that. Okay, so these are the things you have to remember in this experiment. It is important. So so you just go through this one, and again I'm going to give some of the calculation to make you better understand. Okay.